There are over 16 million organic molecules. That's molecules that are based on carbon. So clearly we need some way to classify them, to make sense of them, and to find the patterns and the similarities between their reactions. So we start off by breaking hydrocarbons down into three groups. The first type of hydrocarbon is described as being aromatic. Aromatic hydrocarbons are based on benzene. Benzene is a molecule that has the formula C6H6. It's cyclic, so my carbon atoms form a ring system. It's a hexagon, and then each carbon is bonded to a hydrogen. And I'm sure you're noticing immediately that each carbon is only making 3 bonds. So we have this alternating system of single and double bonds within my ring. And then what happens in aromatic molecules is that the electrons that make up the double bonds merge to form a ring system. And that gives these molecules a huge amount of stability and a unique type of chemistry. So we often see molecules that include a benzene ring, drawn like so, a hexagon with a circle in it. And it might just be benzene, or it might be part of a bigger molecule, methylbenzene, for example. So those are aromatic hydrocarbons. The second type of hydrocarbon contains the most common types of molecules, and they are aliphatic. And I've got a list of them here. So second type, aliphatic. And that's supposed to be an I. There we go. Aliphatic hydrocarbons. And aliphatic hydrocarbons have been further broken down into a series of families. Each family is known as a homologous series. Great word this, isn't it? Homologous. So a homologous series is a family of hydrocarbons that have the same functional group. They have similar chemical properties. We've got the alkanes, the alkenes, and the alcohols. Hopefully they will be familiar from GCSE. But we have lots of others. Let's start at the beginning. So alkanes have got the general formula CnH2n plus 2, and we're thinking things like methane, propane. We can draw them out, and they really are just carbon and hydrogen. So aliphatic hydrocarbons are straight chain, so they don't have the ring system of the aromatic, but they could also be branched. So for example, this molecule here. So I'm going to get lazy and not draw in all the hydrogens. So all of these are alkanes. We've got straight chain and we've got the branch chain, but there's no ring system, so they're aliphatic. Alkenes, general formula CnH2n, have got a double bond. So for example, if we look at propene, it has just one double bond. And this double bond is its functional group. So we would say that the functional group of an alkene is a carbon-carbon double bond. Don't just say double bond, won't pick up the marks. A carbon-carbon double bond. Okay, let's clear some space. Next up we have alcohols. Alcohols have a functional group which consists of OH or hydroxyl. So ones that we might have met before are ethanol. So looks like so, and the functional group there is the OH. You need to be careful when drawing some of these out. So for example, if I were to draw out propanol, but my OH group was in the middle, this is commonly seen. This will get you no marks, because the bond here should be to the oxygen, and it looks like it's to the hydrogen or just to the group as a whole. That's not going to work. So we need to be very careful that we draw out these molecules properly. So those are my alcohols with the OH functional group. The haloalkanes, as you might imagine, have a halogen atom. So we're talking about molecules with fluorine, chlorine, bromine, or iodine in. And the presence of this halogen in the molecule makes these molecules actually quite reactive and very useful. Now we move on to the ketones, the aldehydes, the carboxylic acids. These all have something in common. They all contain a carbonyl group. Carbonyl group consists of C double bond O. So this is a carbonyl group. So in ketones, our carbonyl group is in the middle of our carbon chain. So this here is propanone. And you can see that when we get to naming them, the end of the name of the molecule refers to the homologous series to which it belongs. In an aldehyde, the carbonyl group is on the end of the chain. So I have C double bond O, and that carbon is also bonded to a hydrogen. This would be ethanal, not ethanol, ethanal. And there is my functional group for an aldehyde. This is my functional group for a ketone. With a carboxylic acid, we've got our carbonyl group, and that carbon is also bonded to a hydroxyl group. So we might have met this one before. This is ethanoic acid. And here is the functional group for a carboxylic acid. I'm now going to jump to have a look at esters, because esters and carboxylic acids are very closely related. I'll have my carbon bonded to an oxygen, but instead of to a hydrogen, it's bonded to another carbon. So we have the ester functional group, C double bond O, CO, carbonyl group, in the middle of our molecule. And then that leaves us with amines and amides. So once again, I'm just going to clear a little space here, running out of room. Amines and amides both contain nitrogen. So we're looking at an NH2 group. So for example, methylamine. However, it's important to notice that in amines, the nitrogen doesn't have to be bonded to two other hydrogens. They're kind of based on ammonia, if we think about ammonia, making 3 bonds to hydrogen with this lone pair of electrons. We've got the same thing coming on here. So we could replace each of these hydrogens with carbon methyl groups or a longer chain. They're both amines. And then finally, amides are similar to esters. With an amide, what we have is carbon double bonded to an oxygen, and then instead of to another oxygen, it's to a nitrogen. And that nitrogen might be bonded to 2 hydrogens, like it might be an NH2 group, or it might be something far more complicated. But this is what we're looking for with an amide group. Our functional group is that bit there. And finally, our third classification. So first was aromatic, second was aliphatic, third is alicyclic. And alicyclic hydrocarbons are essentially aliphatic ones that are being used to form a ring system. So our simplest one is, for example, cyclohexane. So this is not a benzene ring. We've got no merging of electrons, no single and double bonds. We've simply got an alkane, in this case, or it could be an alcohol or a ketone that's been bent round into a ring. So C6H12. And then we've got 2 hydrogens coming off each carbon. And you'll notice, I hope, that the general formula for a cycloalkane is that of an alkene, so CnH2n. So no ring system. So aromatic, aliphatic, they're the 2 you're going to come across all the time. You need to be aware of alicyclic. If this has been useful, hit the subscribe button, the effortless way to support your studies. And by clicking the link in the blurb below, it will take you straight to the Crunch Chemistry School, where you'll find all the resources you need to get that A-star grade at A-level. Together we can do this.